Okay, today's lesson is on how we use an angle bisector and vertical angles in congruent triangle proofs. So if you take a look down below in the given, it will be a clear indication that you have an angle that's being cut or bisected in half. So BD is bisecting angle ABC. So if you take a look, the middle letter, which is the vertex, B, will get the marking. Let's go to the illustration, add angle B, and again, I like to number my angles. We're going to say that angle 1 will become congruent to angle 2. So this is a one-step routine. So in your statement column, we're going to go to the picture, and according to the illustration, angle 1 became congruent to angle 2. So when we're writing it, the reasons will be to declare that the triangles are congruent by those two equal angles. Okay, let's take a look. Let's take a look at an actual official proof using the angle bisector routine. So as you can see, the quote is my reasons to angle bisector, which divides an angle into congruent parts. So back to the givens, BD bisects angle ABC like we saw before in the actual same illustration, just adding it on to a proof. We have B being cut in half, angle B, and we draw our angles by 1 and 2. So we have another given. Let's go down to the rest of the page. So if you take a look, we also have perpendicular line routine here. So we're going to indicate that angle ADB will be congruent to angle CDB. So now we cannot number those angles 1 and 2 because we already have a 1 and a 2 in the illustration. We will use the next two consecutive numbers. So we're going to say angle 3 is congruent to angle 4. We need something else. We no longer have any more given, so we're going to go ahead and mark that middle diagram. And the conclusion here as to these two triangles being congruent is to angle side angle. Now when we actually start writing, remember the first step, the first step would be always to start with the first given. Let's just go back to the pen. Okay, so my first given, which would be my step 1, would be to say that BD bisects angle ABC. That was given. My step 2, which was my new step, so that gets a star. Only one step routine here. We're going to conclude that angle 1 was congruent to angle 2. And my reason, as we saw before in the quotation marks, is your definition of angle bisector. An angle bisector divides an angle or cuts an angle into congruent parts. Moving along to the rest, go back to the givens. My next and last given is BD is perpendicular to AC. And we know before, I stated earlier, that's a two-step routine. I will not give it stars because that's not the new stuff for today. My step 4 and 5 will be to conclude what perpendicular lines do. So I went back to the picture. Now my right angles were located by angle 3 and angle 4. So angle 3 and angle 4 are right angles because your definition of perpendicular lines form right angles. Ooh. This pen is not cooperating with me. Excuse me. And we know that all right angles are congruent. So my next statement is to say that angle 3 is congruent to angle 4. My reason is all right angles are congruent. Okay, now remember what we stated earlier. We need 3 congruents in the statement and column between sides and angles, and we only have 2. So my next and 6th step is to go ahead and talk about that reflexive property that happened on BD. So BD was congruent to BD, and that was called the reflexive property. Okay, so now I can close up the proof, and the last and final step, remember what we stated earlier, is that the proof will be my conclusion. So triangle ABD is congruent to triangle DBC, and my method, which we already stated earlier, was by angle side angle congruent to angle side angle. So as you can see, the angle bisector routine is clearly different from a line bisector, is that here we have a clear indication that the angle was being cut in half. And the next and last routine for today would be to look at vertical angles. So vertical angles we saw in the beginning of the school year algebraically. If the angles were across from each other, they were congruent. So vertical angles is used like the reflexive property. It's used only when it's needed. So remember, when you have insufficient information in the givens, we use vertical angles. So you'll usually see, again, 2 triangles linked together by vertical angles. So you can see either the triangles drawn together by where the angles 1 and 2 are, or they'll be drawn to where the 3 and the 4 are. So the conclusion is here is that angle 1 is congruent to angle 2 because vertical angles are congruent. Or you may have the triangles drawn left and right where the angle 3 and the 4 are. So I'm going to write, or you can conclude that angle 3 is congruent to angle 4. So you'll see again, vertical angles is used like the reflexive postulate. So it's used when it's needed. And you'll see and notice the triangles are linked together by that X. So vertical angles are congruent. Let's take a look at it in an actual formal proof. So here we have again the quotes is what's in the reasons column. Vertical angles are congruent. Let's see how and when it's used. So according to the givens here, we have a clear indication that we have a line being bisected. So FO is actually cutting AS in equal halves. So AS is being cut in half. So we have to first clearly state that T is the midpoint of AS. Then AT would become congruent to TS. My last and final given here is angle A is congruent to angle S. So do you see that I need something else here? So I'm going to go ahead and use the vertical angles located by angle FTA and STO. And like I stated earlier, anytime you have congruent angles, you want to make it nice and easy. Number those angles. This way it'll be easier to talk about. So we have triangles being congruent by the angle side angle theorem here. Again, when we first start writing, always start the proof with the first given. So FO is bisecting or cutting AS in half at its midpoint. So there is the first given. So we learned yesterday that this would be a 2-step routine. So step 2 and step 3 would be according to my line bisector routine. So you can see clearly that this is a line cutting another line in half at its midpoint. So my next step would be to state that T is the midpoint of AS. And here's your definition of line bisector. So line bisectors cut a line through its midpoint, or divide a line at its midpoint, or intercept a line at its midpoint. So let's just say are drawn to the midpoint. The Then the next conclusion went based upon, again, still on the line bisector routine. Now we can clearly state that AT became congruent to TS, and this was your definition of midpoint. So the midpoint is actually doing the cutting in half. So midpoint divides a line segment into congruent parts. Continuing on, go back to make sure you stated all the givens. We have one more left. Angle A was congruent to angle S. That was given. Now here comes step 5, which is my starred step. And that is to state those vertical angles. So again, as we saw, we ran out of givens. So you look at the picture, and if the triangles are linked together by an X, you use your vertical angle theorem. So if you take a look here, angle 1 was congruent to angle 2. And again, that's the start step. So vertical angles are congruent. And my last step, make sure you have 3 congruents in your statement columns between sides and angles, and we do through steps 3, 4, and 5. So my last and final step would be the proof. So let's take a look. Scroll down a little. So triangle FAT became congruent to triangle OST, and my method was angle side angle congruent to angle side angle. So as you can see, quickly summarizing, that vertical angles are used like the reflexive postulate. It's used only when you need an additional piece of information in the given. So you'll see sometimes there's vertical angles going on in the illustration, in the picture, but you don't need to use them because you have 3 things in the given. So here, you only had 2 facts in the given, or definitions, and that was only, I should say, one definition, which is a line bisector, and the other one was a pair of equal angles. Okay, so you needed a 3rd piece of information to conclude the triangles were congruent by the angle side angle method. So again, vertical angles are used like the reflexive postulate only when you need to.